did not download. Okay, so we started with talking about relationships. Remember, those are represented by a diamond, and they always go between two entities. Okay? Entities are represented by rectangles, and they represent groups of similar things, basically. So we were doing this hospital example. Doctors, there's a lot of doctors at a hospital, so that we need to keep track of, so that's a good one. Appointments, patients, rooms, prescriptions, these are all things where, we have a bunch of them. They have a bunch of different properties and things that we need to store, so we can use these as our entities. How did we decide on these? Well, if you are consulting, you would just ask, you would say, well, what data do you need? Basically. It's not that simple. It takes at least a year or more, a little less, I don't know. Depends on the size, but they collect the information by watching the organization. Okay, so when you're adding your relationships, you draw a line from entity to relationship to entity. Okay, and so here, it's easier, I think, to take each pair of entities and think about how they relate. Okay, you can end up with cycles in your relationships, and you want to try to avoid that, but there's a lot of things you can adjust when you're creating an ER diagram for a database. There's so many little things you can adjust, and you're trying to get the most efficient combination in your entity map so that you can build it with SQL. So it's like your blueprint. So you cut out the things you don't need, only focus on the things you need. Okay, so here, I'm having deja vu. I must have said this already. Doctors see many patients. That makes sense, right? Now, if I didn't specifically say in the prompt, doctors see many patients, what that means is, in this hospital, you get to decide. So if you want a hospital where doctors only ever see one patient ever, you would put a 1 there. That's pretty ridiculous, so, I mean, could happen, I guess, but the most logical choice would be many on this side, and how many doctors can a patient see? That's also many, so this would be a many-to-many relationship, M and N. Okay? But before you start deciding the relationships, you should connect your entities together. All right? So here, we do have a cycle. Doctors prescribe prescriptions. Doctors can prescribe many prescriptions, but a prescription can only be prescribed. So each, like if you get a prescription, only one person is gonna prescribe that to you. Someone else could prescribe it to you later, but that would be a different prescription that we would keep track of separately with a different date and potentially different doctor. Could be the same doctor, but it's only ever 1 per prescription. So that's a one-to-many relationship there. And we want to talk about logically. So doctors, they write out the prescriptions, the patients take those prescriptions, and we already talked about doctors and patients. So, not to confuse you, but a prescription is only prescribed to one person, but a person can have multiple prescriptions. That means both prescriptions and patients is a one-to-many, and prescriptions to doctors is a one-to-many. And the one side is prescriptions are prescribed to one patient. Prescriptions are prescribed to one doctor. When you have that, and the ones are facing two different entities, and the manys are facing one, you can actually convert this into a this two one-to-many relationships into a many-to-many relationship. Okay. This is one of those things where logically you just build it out, and then you look at it again and you look for any weaknesses that you can improve on. So that's basically, yeah, I'm looking at this, and that's what I was like, I just told you cycles are bad. And then the first ER diagram we pull up has a cycle in it. So the reason this is a cycle is it should be patients go to appointment, and a doctor is assigned that appointment. So yeah, or you can use a many-to-many, but you could break it out into two one-to-manys, because an appointment only ever has one patient, and an appointment only has one doctor, unless you're really sick and you need multiple doctors for a single appointment. Again, if I didn't say it specifically in the prompt, you're allowed to make whatever assumptions you want. You just have to be able to, if I question your judgment, I'm doing that to try to help you make better decisions, but I want to hear why you did it that way, because I don't always think of everything. It's really easy to plan out a database, and it's really hard to build it and implement it in a large organization. So the worst thing in the world is to implement something, and then after your year of consulting and building, and you implement it in the company, and then you find out it doesn't work or it has crazy load times or something because your records are pulling up wrong. So that's the kind of thing we want to fix while we're making the ER diagram. And that's why I start this class about learning about database design. Okay. If you don't understand database design, it's really easy to make a terrible database. And if any of you are planning to work in programming or web development, you will probably need to use a database. And if it's already been built by someone who just went to a website that taught you SQL, it's going to have a lot of the issues that I'm teaching you to avoid. Okay? And then you have to do workarounds, and it's a nightmare. So you want to build it right, plan it out right from the beginning. That's why we spend so much time on the planning. Because if it fails, the company might have just lost $1 million on all that. Okay. So now that we know how our things are fit together, okay, I already went over this. I think, oh yeah, because we're down here. Okay. So this is the ER diagram that I came up with. First draft, again, creating an ER diagram is an iterative process. I didn't explain what that means before. It means you're going to make it, and then you're going to edit that one, and then you're going to edit that one, and you're just kind of shaving it down to the bare necessities. Okay? It'll work a ton of different ways. And sometimes it'll, a lot of times it'll still work if things aren't the most efficient. But if there is a way to make it the most efficient, why not do that? It gives you a huge advantage over other people that don't know how to do it, that get hired, because you'll see this if you get a job in it. I've seen it so many times. Okay, primary and foreign keys, I'd mentioned those before. I'll talk about it again. So inside of an entity, all right, primary and foreign keys. Let's talk about doctors and appointments real quick. What do you think the primary key would be for doctors, and what do you think the primary key would be for appointments? So, doctors, remember, a primary key is some data, so some value that's unique between instances of the same entity. That's a fancy way of saying, everybody needs a different name, basically. So, we can't use name, though, as the primary key because people can have the same first name, same last name, and even live at the same house. So you can't use address. So what is actually unique? Well, probably something like employee ID number. Social Security number is unique, but there's a lot of business rules regarding using Social Security numbers. So you would, at this point, try to avoid using Social Security number, because it's not that easy to, or it's not that hard to switch to it later if it's the best solution. Some organizations really need people's Social Security numbers, and some really don't. Okay, so primary key of doctor would be like employee ID or doctor ID even, because there are going to be different employees that we'll probably keep track of that I haven't included in here. Appointments. What do you think a good primary key for appointments would be? Well, this is a situation, again, where we have a one-to-many and a one-to-many relationship on both sides of this. And the ones are pointing at two different entities, and the manys are pointing at one. Okay, so this could be converted into a single one-to-many. But the way it is, we could technically use appointment number. We could use a combination of the time and the doctor, because that would prevent anyone from being scheduled at the same time, because if you tried to enter that into the database, it would say that value is already in there. I guess you would have to include the day, time to the nearest minute, and depending on how, anyway, I'm running through the whole series of questions I would ask them. Anyway, you could just use appointment ID. We'll talk about composite keys more later. Very soon, actually. Okay. So those would be good for primary keys because it's unique. Okay. Just every appointment will just get a new appointment ID. So the first appointment we ever have at the hospital will be appointment 1. The next one will be 2, and so on and so forth. Okay. But what about foreign keys? All right. So we have to deal with foreign keys in every type of relationship. Okay. And I added this one-to-one relationship in here because, I don't want you to be surprised if you see it. It's just fairly rare because I feel like one of the only reasons it's done is to be more efficient on loading specific information in certain situations. So that one you really have to, know what's important to decide that. Okay. But let's take a look at a one-to-many relationship. Let's go back to doctors and appointments. So what was doctors' primary key? It was doctor ID. I think I have them down in here. Okay. Let's just do it this way. So in a one-to-one relationship, here we have two entities and the relationship. These down here are the information that would be stored in a table. This is basically the table view of what this will become. This ER diagram will be a blueprint for designing your tables, and then from your tables you will design the SQL to create your database. So that's what these are. These are just tables of the rows are records. Okay, you can call them rows, you can call them records, you can call them tuples, T-U-P-L-E-S, tuples. If you're doing research, you're going to see all three of those terms used. They mean the same thing in terms of a table in the database. The first row here is the list of attributes that this table has. So this is the contact info, patient contact info. So we need a primary key, so we use patient ID. So those just have to be different. And then patients, well, they also need an ID. So here, we're using patient ID as the primary key, and we're using it in both. Because it's a one-to-one, every record in this first table will relate to exactly one record in the other. So, the primary keys are patient ID. The foreign keys here, the foreign key is also patient ID. And you can do that on either side. It doesn't matter in a one-to-one. You could use the patient ID and patient contact info as the foreign key, or you could use patient ID in patient's table. Now, since patient contact info is kind of a sub-table of the patient's table, that's probably where you would use this one as the foreign key, because you couldn't have contact info if you didn't have a patient. So, all right, so we're done with the one that we probably won't see very often. Now one-to-many. This one we'll see all the time. So again, we have the relationship at the top. It is a one-to-many relationship, and I've listed the primary keys here. And let me just go back real quick. You may notice that this foreign key is the same as both of these primary keys, but the reason it is patient ID is because to create a relationship between two tables, you have to use the primary key from one table as a foreign key in the other. And there's no rule about if whether a primary key can be a foreign key or not. In a one-to-one relationship, it can be both pretty easily. Okay, so keeping that in mind, because this one has an illustration and I want to explain what's happening here. So, primary key patient ID, primary key appointment ID. So, pretty straightforward. Coming up with a primary key is probably the easiest thing to do. Foreign key. Once you've decided the primary keys and the type of relationship, you don't even have to decide what the foreign key is, because it's always going to follow the same rule. The primary key on the one side of the relationship is going to be the foreign key inside the many side. So patient ID is the primary key of patients, and it's the foreign key of appointments. So if we look at the appointments table, it has appointment ID and patient ID in here. Why do you think we need to include a patient ID in the appointments table? What is useful about that information? What does that tell us? Okay, and we have two people watching, so see if you can think about it, and then pause if you want, but I'm going to go ahead and talk about it. The patient ID here tells us, this is how we read this. Appointment 1 is in the red room, and it's patient 1. when someone looks at that record, we, later on you'll see this, we can present it however we want. We can actually say, okay, patient ID 1 is Jim Smith, and so when the computer outputs this data, we wouldn't tell them just the patient ID. We could give them the patient ID, the first and last name, the location, all right? Now, if we look down here, why does Jim Smith have 2 lines drawn? Okay. Take a look, think about it. And why does Bob Anderson only have 1 line here? So Jim Smith is pointing at appointment 1 and 2. Bob Anderson is pointing at appointment 3. Why is Jim Smith pointing at these 2? Because they have his patient ID. He is the one that's going to go to these appointments. Bob Anderson, his patient ID is only in 1 record, so he has 1 appointment, all right? And so that's what the foreign key does. It connects tables together. That is truly what a relationship is, okay? It's when you're looking at the diagram, you know, I'm mostly expecting you to learn the terminology and the actual diagramming principles or standards, whatever you want to call it. The Chen's notation. We're using a very simplified Chen's notation here because of the examples we're using are fairly simple. Okay, so you always take the primary key from the one side and use it as a foreign key in the other side. Another thing, and you can see it here, foreign keys do not have to be unique. Okay, primary keys do. So if a primary key is a foreign key, it also has to be unique. But if it's just a foreign key, it does not have to be unique. Okay? Because if the patient ID had to be unique, you can always logically figure this stuff out. Just think about it. What if this patient ID always had to be different? That means Jim Smith could only ever have one appointment. And that's not what we diagrammed here. We said patients can have many appointments. Okay? So every line drawn from these guys could go to multiple things. Okay? But every line coming from these only points at one person. So 3 points to Bob Anderson, 2 points to Jim Smith, and 1 points to Jim Smith. Okay? You'll never see 2 lines coming out of this. Okay? You won't see lines coming out of anywhere unless you use Access. It has a nice little thing in there, graphical representation of relationships. Your graphical representation of the relationship is the ER diagram that you created. Okay, and for these, if you're working on ER diagrams, you know, I have shown you I've given you the link at least to draw.io, free diagramming web-based tool, so you don't have to install anything. Okay, and then from here I'm just going to create a new diagram, and I can just create a blank diagram. You could do this on paper and scan it. Some people like handwriting these better. The thing is, the way they grow by adding entities and relationships, it's really hard to plan out where things are going to go. So you might have to erase, or it will look wonky. If you do it digitally, you can just drag things around and restructure it fairly easily. So that's what I recommend. Okay, I don't know what it's asking me for here. Oh, save as. Okay. We'll just throw it in here because I'm going to make a junk thing. So it's making me save it to my computer so that I don't lose it if computer crashes or power goes out. Okay, so building your diagrams is as easy as dragging these out here. Okay, let's see. And maybe we'll have doctors, and then we'll have patients, and then you put in the relationship. Okay, and then you can use these tools. Right here, you can click that, and it'll connect to the nearest thing there, and this will connect here. Now, you'll notice in our ER diagrams, the lines do not have arrows, so to change that, you just click here, and then you choose rounded is fine, probably. No, that's not what I'm looking for. Here it is. The head. What kind of head do we want? We want none. Okay. And once you change that setting, so I'll delete this one. I think once you change that setting, from then on, the lines you create will follow that, which is nice. So you don't have to make sure you set that first, or else you're going to have to go in. You could probably select these, this, and if I hold Shift like that, I can grab both of them and then change them all at the same time. But just change it for the first one immediately, and then you won't have to run into that issue. Okay, so let's say I need to move this so I can see better how these are related. You know, the lines adjust, which is really nice. No erasing. Okay, anyway, if you're going to use this to turn in, okay, you actually have to go to File, Export, okay, and then if you recognize, these first two are image files, so you can choose either of these, then it will download your diagram as a picture file, so you'll save that somewhere where you won't lose it, and then you can attach that to the assignment, or if you're in the Word file, you can just put the picture in the Word file under the exercise, and that's pretty straightforward. Okay. Now the most complicated relationship. It just has an extra rule in it. So here, doctors can see many patients, patients can see many doctors. Primary key of doctor is doctor ID. Primary key of patients is patient ID. Okay. You don't see any foreign keys inside the entities in a many-to-many relationship. Okay? What happens with a many-to-many relationship is it actually becomes its own entity that represents an instance of a relationship between two other entities. If that doesn't make sense, it's okay, because just like the other two, once you decide on your primary keys and your relationship types, you don't have to think about other than, you know, you're not making any decision. You just have to, you always follow the same rule. Okay, so in a one-to-many, we take the primary key from the one side and put it in the many side. In one-to-one, you can do it either way. But with a many-to-many, you will create a relationship, a new table, okay, and its attributes at a bare minimum need to be the primary keys from both tables, okay? That will become those attributes inside of this new table are individually foreign keys back to the other tables. So, again, if you just follow through, it all makes sense. It's a lot to take in the beginning. All right, so here we have a patient ID of 1, which is Jim Smith, and we have a doctor ID of 3, which is Sarah Sweedler. So if I have 1, 3 in this table, which represents the relationship between these two entities, what does that mean? What does 1, 3 mean? What does 2, 3 mean? And what does 2, 1 mean? Okay? What that means is Jim Smith has Dr. Sarah Sweedler. Sally Jones also has Sarah Sweedler, but Sally Jones has another doctor, Greg Ackerman. All right. So when a many-to-many, you always follow this step, okay? And so look at so down here where I'm listing the primary keys and the foreign keys, I do want you to write that when I'm asking you to put in the primary keys and foreign keys. What I'm asking you to do is include text telling me what the primary key and the foreign key are, so that I can see that you understand how the relationships work. So in a many-to-many, you actually have to put these on the relationship. So under the relationship here, I've placed them. Like I said, patient ID is a foreign key, doctor ID is a foreign key. The primary key has two attributes, okay? So what that means is you can combine attributes to form a primary key, okay? What that means is the combination of these two values has to be unique. So if I have a 1-3 here, I cannot have another 1-3 anywhere in here, because that tells me that Jim Smith's main doctor is Sarah Sweedler. If I put that in there again, it's redundant data, okay? So what we do to represent that primary keys in this join table is you just use those two the foreign keys from the two tables. You just make a composite key like this, okay? All right, so that's called a composite key. Okay, so we talked about primary and foreign keys. So you can look at this diagram that's completed up to the point where I added in the primary keys and foreign keys, and you'll see everything that I talked about is every one of the relationships follows that same thing. So when you have all the entities out here, it looks like, you know, a mess. But once you understand what each of these are, it makes sense. So here we have the doctors and prescriptions. Okay, I'm glad I talked about this because we have so doctors prescribe prescriptions, one-to-many. Patients are prescribed prescriptions, many prescriptions, but to only one person per prescription by each doctor. So take a look. If we were going to represent the relationship between doctors and prescriptions by using foreign keys, what foreign key would I add to prescriptions? Or what foreign key in prescriptions represents the relationship to doctors? That's doctor ID. We also have another foreign key, patient ID, but that has nothing to do with the relationship between doctors and prescriptions. The reason that's in there is because of the relationship between prescriptions and patients. Okay, so at this point, I don't even need to logically think about the relationships. If I just want to get the keys in there, all I have to do is look at each, I almost called that a triangle, each diamond, and see, okay, this is a one-to-many, so all I have to do is throw this as a foreign key in here. This is a one-to-many, so you always take the primary key from the one side, put it in as a foreign key in the many side, okay? Once you've added those foreign keys, you can just put them together, or I'm sorry, once you have the foreign keys in there and a one-to-many, you're done, okay? Now you know when you build this table, at a minimum, you'll need these three fields. We'll add more, but these are important for the structure of the database and the way the tables are related, and is one of the most important things to speed up access to your database is controlling how you set this up. Okay, so if I can reduce the number of attributes I need, if I can reduce the number of entities I need, all of those things go really far. Okay, you want to reduce redundancy for sure. So you don't want extra copies of things you don't need. They just take up space and time. Okay, anyway, so we saw some one-to-manys. Here's a many-to-many between doctors and patients. Okay. Primary keys are added as foreign keys in the relationship. It will actually become its own table with a primary key of a composite primary key of both attributes. Okay, and so you can look at the other relationships and see that I followed this rule for every entity and many-to-many relationship. Or every relationship I've set up the foreign keys and the primary keys for this correctly. So if you want to take a look at a diagram you've created and you want to double check, you can say, okay, one-to-one, here's how we did that, or one-to-many, you can take a look at that. Okay. So one of the more important parts of designing an ER diagram, and I know I've said this twice already, it is an iterative process. Okay? So whenever you think you're done, you're not done. Okay? In this class you are, but in reality, you're going to spend a lot more time. You only have one, most likely you only have one database to diagram out. It's going to be huge, but potentially. But once you're finished, it's time to go back and double check everything. So for example, some of these questions that you might ask of the organization or of yourself. Do we need a table to keep track of different prescription drugs and a table to track when those drugs are prescribed? By who to who? Okay, so I don't even see drugs in here. Let's see. Oh, the point is, do we need a table? So do we need to add a new entity called prescription drugs? And then inside of there, the records would be like, I haven't been sick in so long. Penicillin, that's penicillin, and then it would have some properties, like these are the medicines that you can't take this with. That would actually be another table with relationships. That would be a whole thing, okay? Should we tie the act of prescribing drugs to the appointment in which it occurred? So remember, I said you don't want cycles. You want to try to avoid cycles. So here, because patients is related to appointments, doctors, and prescriptions, there's going to be 3 copies of that, or there's going to be a lot of copies of that foreign key. Okay, there's one. Here's patient ID here, patient ID here, patient ID here. Okay, if we could somehow combine these or add something that reduces the number of relationships, then we can make it more efficient. Okay. I need to stop moving this up and down while you guys are trying to read it. Okay. Should we? Okay. Try adjusting your model to meet these requirements. So if you guys want to try this, see if you can refactor this to include prescription drugs as an entity. Think about which tables that would connect to. Okay, which entities would it have a relationship to, and what would its primary key be? Okay, and then what would the relationship type be to the entities, and put in the foreign keys. Okay, so try that, and if you want to email it to me and ask how you did, I can take a look at that. Or if you're having problems on any of the homework, definitely email me. And I've done Zoom meetings with students one-on-one, so I can share my screen and you can share yours, and we can talk, and I can walk you through things, which is much easier in explaining technical things like this than it is through email. So I'm totally okay if you just have a simple question. Definitely email, but if you want a better explanation or a walkthrough, email me and we'll make an appointment. So, all right. So we are up to ER Diagrams Homework 1, which was due September 7th. So if you haven't done it yet, try doing it on your own, because what I want to do is go through, maybe I'll go through one or two of the trickier problems here, and then if you want me to do more, you just have to ask. If there's one that you weren't sure about, just ask. Okay, so let's take a look here. Okay. I keep adding I've been adding problems to this, and they're more complicated towards the end, I think. All right, so let's try 10. Create a database for a website that matches employers with new employees. All right, so what is the first step? That is listing your entities. All right, so I'm going to delete this, and I'm just going to add this in, and we'll make a list using this. Entities. All right, so basically, what is that called? One of those job finding agencies, but it's online. What are those called? Can't think of it off the top of my head. Okay, let's center this. Nope, nothing like that. There we go. Down here, go back to left align, but we will put bulleted list. Nope, it's not going to let me do that. It has to center the whole thing. Okay, anyway. So think about what data we need to store. All right. So we have employers and we have employees. Prospective employers, prospective employees. All right. So employers, employees. All right. We could have jobs, because some employers are looking for more than one type of employee. So we can keep track of those with jobs. So employers will be able to create new jobs, and those will get stored as individual records tied to them by their employer number in our website, to keep track of which places have which jobs. Let's see. So I think that's actually enough for this one. So I like you guys to kind of try these on your own in the beginning. So if you guys have just created all of your diagrams already, and as you're watching this, you're noticing like a bunch of mistakes you made, I will, what I'd like to do is have you understand the mistakes you made and what the correct way is, because that's the point of this class. So whether you do it by the due date or you do it by the end of the class, it's going to be the same. So if you wait till the end of the class to do all this stuff, though, it's not going to work because it's fairly complicated all together, but in chunks it's much more digestible. Okay, so next step, I've listed my entities. All right, so I probably do that on a, in the corner or something. The next thing is to put them in So we have employees. Okay. We have, you can copy and paste these two, which is nice. We have employers. And we have jobs. Okay. We're gonna want to keep track of, it would be really nice, and I've seen websites that do this, if we could store on our website employees' resumes and cover letters and transcripts, basically everything you need to apply for a job. If we could store that for employees, we could save them a lot of time of typing. So I just thought of a new entity. So jobs, employees, employers, but we want to keep track of also documents. Okay. All right. So I think that's good enough for now. So we need, what's next after we have our entities? We need to put in the relationships. So the employee can upload their resume and transcript documents so that they'll automatically be included with an application. Sometimes, if you're applying for a lot of different jobs, you may gear your resume differently. So maybe you'll have multiple resumes for different types of jobs you want to apply for. Okay, anyway, that's definitely, we want that relationship. Okay. Does documents relate to jobs or to employers? I don't think so. Maybe you think differently, and if you map that out and we talk about it, we can figure out, because there's never one right answer. There usually is a best answer, but finding it takes a lot of time. The more time you put in, the better it's going to be. And not that I expect you to put in copious amounts of time here, but if you were doing this as a job, it would be expected. Okay, so we know these are going to be connected, so stick that there. Okay, so it remembered my line rules. We'll stick that there. Okay, so employees, upload documents. And the names on the relationships are really for the person designing the database to understand that relationship. Okay, so sometimes you read them one way, sometimes you read them another way, but employees upload documents, but documents are uploaded by employees. So that's the relationship. What type of relationship do you think this should be? Think about it for a second. Should it be one-to-one, one-to-many, or many-to-many? So this is where you just apply your logic. So this is one you have to figure out based on, it's supposed to be based on the analysis, but I didn't say anything about documents in the prompt. So I'm just making an assumption that I think it would be a better website if prospective employees could upload documents to use in the applications. So that's why I included that. See, I can explain why. So if you do things differently than me, as long as you came to that conclusion using logic and it makes logical sense, it is a good answer. Okay? And so what else? Okay, so jobs. So employees apply for jobs. Employers post jobs. All right? So we'll put those in there. You can definitely let's see. You can definitely fast forward this part. If you want. Okay. Jobs are posted by employers being able to use a computer well helps a lot. So when you select this once versus selecting inside of the text, it's actually, you're selecting actually something different, so you have to be careful. So I want to select this object, Control C, Control V, and then I can, as long as I see the four-headed arrow, click and drag. That four-headed arrow represents moving. So it's a context-sensitive cursor. So if I click out here, I'm not going to be able to move it. This is the selection cursor. This is the move cursor. And then here, this looks like a custom cursor they added because it's all jagged and weird looking. But it has a plus sign, so you just have to know that when you see that plus sign, it's going to do what it does when you click this. So anyway, connecting these. Ooh, got a curly one there. All right, it doesn't have to be lined up perfectly. I think I set these lines to have a round curve on accident. So you can do rounded, curved, or you can stick to sharp. Okay, doesn't really matter as long as I can see where the line's coming from and going to. All right, so we have relationships and put in. Now we need to decide what type they're going to be. So again, I was talking about this is the part where you apply the logic. So employees upload one or many documents, and documents are uploaded by a document. So one employee can upload. So I'm going to say this, but I'm going to try to explain it at the same time. So when you're thinking, if you say it out loud, it becomes really obvious, okay? But when you're saying it out loud, you start at one entity and you think, okay, one record in this table, so one employee, okay, and this has nothing to do with the relationships yet. You think about one employee. How many documents can one employee upload? One or many? Well, we already said we wanted many, so I can put an M on there. So you just select the line and you can type on it. So a single document would be uploaded by how many employees? One or many? If a single document can be uploaded by multiple employees, that just doesn't make any sense, because when you upload something, it's always from one computer, and I'm imagining this website would have an account information, which would be in this employee thing, and so as part of that account, your uploaded documents would be attached to one person. So each document would be uploaded by one employee. So this is a one-to-many relationship. Okay, and remember, one-to-many, it does matter which side has the 1 and the M, so those are tricky in that you have to double, if you just do the logic thing I just did, you can do it pretty easily. Okay, employees and jobs. So an employee, whoops, why did I name this? Oh, I never changed it. Okay, an employee applies. One employee can apply to how many jobs? Well, we would be a really bad website if you could only ever apply for one job. So an employee can apply for many jobs, and then one single job can be applied for by one employee or more. Well, employers wouldn't use our site if we only ever gave them one option, or we limited it to the first person that applied. That would be terrible. So we want multiple employees, multiple people to be able to apply for jobs. Okay. it's kind of weird calling this employees, because that kind of says they already have a job, which you could already have a job when you're looking for a job. Professional tip: if you have a job that you like, you may be tricking yourself, and you should always be applying to new jobs, okay? Whether or not you decide to take the job, you'll be surprised at what kind of opportunities you'll uncover. So a few years ago, I started applying to a different job every day, or not every day, geez. Filling out applications is the worst. No, I lost my train of thought. Anyway, applying for jobs. Oh yeah, I was applying for jobs once a month. Getting the interviews is awesome first, and then getting offered the job. Well, after that, if you get into a further interview, that's pretty cool. Like, it makes you feel really good about yourself. And then, if you actually get the job, you can say, all right, do I want to move to this new job? If it pays more, or I don't get along with the people I currently work with, or it has benefits, or it's in a place that's nice and the place I work is not nice. But you get to decide, and it's no problem if you say, you know what, take me out of the running, because their application process, they have people they can go to immediately after you, so it's totally normal to do that. And then they have your information, so if you ever apply again, or if they have some kind of other opening, they may contact you. So it really gets your name out there. But anyway, if you don't get the job, you can just say, I've got a job. Oh well. Big whoop. I'll apply to another one next month. Or next week. If you don't have a job, and you want one, I highly recommend applying for jobs every single day. You have to cast a very wide net. And unfortunately, if you have an associate's degree in this kind of field, you really have to make yourself stand out, because you're competing with people who are going to have maybe bachelor's degrees and stuff. I'll tell you this: if you do this program and you survive through the programming program, for everyone else, I guess this is kind of a moot point, but if you're in programming major and you survive this course, I'm confident that if you get through every course in this program, you are ready to become like a junior developer, web developer, or at the bare minimum, a QA, quality assurance, who basically is like a video game tester for software that isn't games. All right. Okay, back to the diagram. Man, I need to stop rambling. Okay, so jobs and employer. So an employer, I'll just move a little faster here. An employer should be able to post, one employer should be able to post multiple jobs. A job should only come from one employer, right? Does that make sense? Doesn't really, you would never be hired by two employers for one job. That would be awesome, but it would be very unethical. So here we go. So a job can only ever be posted by one employer. Okay? All right. So we've got our relationships in. Now let's add in our primary keys. This is pretty easy. This will be an easy one. So employees, primary key will be employee ID. And I shorten these so I don't have to write out all the words. Hey, you guys can do it too. This is not a typing class. Being able to type helps. So, all right, so there's our primary key there, and now I can just copy this. Make sure I select it correctly. Copy it for here. So every one of these entities is going to need primary key, right? This is why doing this digitally is good, because if I put this in a place, you know, that blocks this from expanding out, I can just move it. Okay, so there's my primary keys. Now it's time to put in the foreign keys. So at this point, we have our relationship types, one-to-many, many-to-many, and we have our primary keys. Oh, I guess I should change these. So how about for document, we use document ID. For jobs, let's see if you guys can guess what we're going to use, job ID. And employers, okay. Names of primary keys do not need to be unique. The values do. So this primary key, EID here, that's the EID inside the employers table. It is not related at all to the EID inside of employees and employers. Okay, so this is employers.eid and this is employees.eid. Okay. So this one, okay, so we can keep that there, that's fine. Or you can change it too. It's really confusing if you use two primary key names that are the same in a many-to-many relationship. So let's do, we can call it EMID. It's really, you know, it's a good idea to make the names so that people understand what the attribute is, okay? Because once you're done here, anyone who's developing the software that will use this may have to grab the data out of these tables. And so, you know, if your employers have an attribute called wiffle ball bat or something, and you call it that, but that's their name, it may confuse anyone that's trying to use that. So you are free to name things whatever you want, but it's within, like, you know, usefulness. So primary keys, pretty straightforward. But let's do the foreign keys now. Okay, so what is the rule? You take what? You take the primary key in a one-to-many, you take the primary key from the one side. Okay. And what do you do with it? You put it as a foreign key in the many side. So you select this, FK, oops, I'll capitalize that to be consistent. Okay, so we just created the relationship between these two tables. Okay, so we can see all the documents that each employee has uploaded, and the employees will be able to see their documents based on the EID in the documents table. All right, let's do the other one-to-many. Okay, so here it's the one side, right? We grab the primary key, and we stick that in here as foreign key. Okay, so now I have this relationship done and this relationship done. Now we'll move to this one, many-to-many. All right, remember there's an extra step in a many-to-many, and that is creating a new table, or a new, basically the relationship becomes an entity, and that entity has it needs primary key, it needs a primary key, and it needs a foreign, you know, in this case, it's going to have 2 foreign keys because it's connected to 2 tables. Okay, so what is the primary key going to be, and what is the foreign key going to be? Right? If you remember when we did the example on the slides, with many-to-many, you have 2 foreign keys. All right. You have EID, because that's the primary key from one of the tables, and you take the primary key from the other table, and you stick it right here, so job ID. So now we know that this new entity is pulling information from employees and from jobs, and the primary key is always, at a bare minimum, I should stop saying always. In this class, with the examples that we're doing, your many-to-many will pretty much always use the a composite key of, I'm using a touchpad, I just reached for the mouse. Okay. The combination of both primary keys of the related tables. Okay. So that's EID and JID. So that means every record in this table will have to have a unique combination of EID and JID. So that way we don't have redundant data. And then if we want to, this is going to tell us which employee applied for which job. If we want to know their name, we use the foreign key here. That'll bring us back to here, and we can pull all the information about that employee. If we want to pull the information for the job for that application, all we have to do is find the job with that JID in that record. So hopefully this is helping you see things come together. Teaching it design first like this, again, is supposed to help you when we get to the actual putting things together that do stuff inside the computer. We want to do it right from the beginning. Okay, so I'm showing you this process so that you could after you learn this process, you could take any organization, any business, if you wanted to create a database for anything, all you have to do is follow these steps. So if you're creating it for something for you, all you have to think about is, what data do you actually want to store in that database? So let's say you want to make a database of your baseball card collection or something. You could have a table. You would really only need a table for one table for that, right? And you would have attributes. But once you had it in the database, then you could search that and see what you have, or the quantity, or whatever, however you want to do it. Okay. So anyway, by the end of the class, if you do everything, you will be able to take any organization. Okay. So any kind of business, or if you're in a club on campus and you want to represent the data that organization needs, you will be able to do that. Okay. And everything we're doing is a process. The entire class is just, we're going to start by learning how to design a database, then we'll design it, then we'll implement it, and you will know every step to be thrown right into any kind of database problem. Now, databases, or learning about database, obviously I can't fit every single thing in a 16-week course. So you will have the basics to build off of, that if you ever get in a situation where you need to do something with a relational database and you don't know how to do that, you'll know the basics enough to look it up. Okay. All right. So we have, checking the dates again here. How many people are watching? 2 still. Okay. Okay, what was it? I wonder if I should post this. This is pretty, I made a pretty good diagram here. Okay, anyway. Oh yeah, when is the next thing? So, if you haven't already, let's see how many people have done it. We have the ER diagram quiz, which is going to ask you to follow these steps. You can use, it says quiz, but you can use any resources on it. All right, what I expect you to do, and you can do this one of 2 ways. First, download it don't print it out of here if you can, because it's messed it all up. But if you download it here, you'll be able to either print it out or edit it. If you print it out and want to draw on the quiz, you'll have to scan it back to me. Okay. If you have a smartphone, there's a really great app called Adobe Scan, and I use that basically for everything. For work, it's just a free app, but it's very useful. So you could scan that in with that app, or you can download it, open it, and just type in your answers. If I ask you to make any diagrams, all you have to do is come to draw.io, create your diagram. I would save it afterwards, but to be able to, that just saves it so that you can re-edit it on draw.io. This doesn't give you the file that I need. The file I need, you have to go to export and choose one of these options, either PNG or JPEG, and then once you download that in Word, just following through here, a lot of you guys probably know how to insert a picture in Word, but just in case, if you don't know, that's fine. If you have a Mac that doesn't have Word, you might have to use the school's VM, so contact me and I'll help you out with that, because it does have Microsoft Office. Okay, so here, I'll follow through. I want to post this is my answer to the quiz. Okay, I'm going to export as PNG. Okay, and then do we want a shadow on it or a grid? All right. Let's include a copy of my diagram. Of course. Why else would I do this? Okay. So I'm going to just throw it in. Let's download it to my computer. I need it there anyway. I'm just going to throw it in downloads, and I'll call it 111.png, because now when I go to my documents, I'll be able to see it at the top. Okay, so in Word, once you have the, come here, sit, girl. Sorry, animals are fighting. Okay. If I had an infinite time, I would edit out these pauses. I'm sorry. Okay, inserting the picture. Right. Okay. So I'm going to click. Okay, I'm not even describing what I'm doing. Okay. Go to Insert, Pictures, from this device. This will show you everything. So if I go to Documents now, no, Downloads, that's where it was. Oh, I guess it's sorted by date modified on mine, but if it was sorted by name, one's going to show up first. Okay. So I can delete that later. It's a good idea to periodically clear out your Downloads folder if you're worried about computer space. So I just insert that in. And then once it's inserted in, on Word, if you want to be able to manipulate it easier, what you do is you click this and you choose either behind text or in front of text. If you do behind text, I don't think it'll cover up any text. And then once you do that, that gives you the freedom to kind of adjust and move it around. The default inline with text, it doesn't let you move because it goes with the flashing beam thing, this down here. So you can literally move this as if it was letters, which is not as useful on a quiz where I have things all over the place. Then you want to use behind text, and then you can shrink it down if you need it to fit, okay? And then you move on, okay? So that's how you do that. Anyway, if you are having problems with the quiz, I would not put it off, because if you're having problems with the quiz, you can email me, and I will give you some help. I think I have let me check here. I have something. Did I get rid of that? Okay. I think I have a video. Well, I'll create a video of me going through the quiz, and that way you guys can see exactly what I was thinking for each problem, okay? But definitely start on it now, and or as soon as you can, and ask me if you're not sure what is expected of you for that. All right, so I think that's enough information for today. I'm planning on doing another live stream next Monday, and then we'll move on, and maybe we'll take a look at some of your ER diagrams. If you have questions about anything on your ER diagrams that you're not sure if it's right or not, just bring those to my attention and I can explain it. I will tell you that through the course, we are taking those 10 prompts that I gave you for the ER diagrams, and we're going to follow through implementing those. So you want your ER diagram to be correct enough before you move on to the next step. Because what will happen, and the reason we do these in steps, is because I can look ahead and see what problems we're going to run into for some things. But every step, if you notice something's not working, like if we're putting in the relationships and it's just wrong, eventually we'll get to a point where that is breaking something, and then we'll have to go all the way back to the step, if it's an issue with the ER diagram, we have to go all the way back there and start over with that, because it's an iterative process, like I said. But anyway, it's an iterative process. If you start it on the first day, the quiz, you will not have any time to iterate. I'm just trying to say things that'll get you to do it earlier. Okay. I'm going to end the stream here, so I'll see you next week. Thanks, guys and gals.